All right, so for this game, we have what is largely a sequencing game. So we definitely have kind of a 1 through 5 setup, except this one's a little bit more irregular because we really only have 3 elements to work with. We just have F, P, and T. And moreover, you'll notice that the game never actually tells us that any particular hat has to be used. So for one, there's definitely going to be duplicates since obviously we have more spaces than elements, but it could really just be the same one. Arguably, if we just have 5 Fs on the board as of right now, that is entirely consistent with our setup. So there's a lot of flexibility here. Anyways, next, the rules. So the first rule tells us that at most 2 pillboxes can be displayed. So I guess we can say there's a maximum of 2 Ps on the board. Next, 3 is not one of them. So 3 cannot be a pillbox. And I guess we can leave a reminder here that 3 cannot be a P. Next, 2 is not, or is rather, the same kind of hat as 5. So 2 and 5 are going to have to be the same. Although that could be anybody, right? Because it could still be a P or an F or a T. That's still flexible. Next, if 1 is different from 3, then 2 and 4 would both have to be TAMs. Now, this is a messy rule, but a lot of the time it's not a bad idea to kind of translate these rules and kind of make sense of them, or to simplify them if possible. And there's a bit of a pattern that this rule follows that you really want to recognize as much as possible, which is that in a very loose sense, this rule is almost, it creates an inclusive relationship, and that should be something that you're kind of familiar with. So let's just kind of take a quick reminder. Anytime you have a rule that says something like, if you don't have one thing, then you don't have another, that essentially creates an inclusive relationship between the two. But what that really means, the implication of an inclusive relationship, is that between these two things, X and Y, at least one of them has to happen. When you say that if you don't have one thing, then you must have another thing, that essentially translates into saying that either you're going to have the one thing, or you're going to have the other thing. Now, there are certain rules that will follow this pattern, but in a much more complicated way. But once you tease out the pattern, it can simplify the rule quite significantly. Now, notice what's happening here. If 1 is a different kind of hat than 3, or in other words, we can say that if 1 and 3 are not the same, then 2 and 4 would both have to be T's. So you've got that same kind of pattern, just a little bit more subtly. If 1 and 3 are not the same, if you don't have them be the same, then 2 and 4 will both be TAMs. So in other words, what does that translate into? That translates into essentially saying that either 1 and 3 will have to be the same, or alternatively, 2 and 4 will both be TAMs. And that's a much simpler rule, and that's to kind of follow it. It's a much easier one to handle. We can basically say that at all times, either 1 and 3 will be identical, or both 2 and 4 will have to be TAMs. And in fact, when you look at this rule from this perspective, you'll notice that this is kind of significant, because whichever way you go, that's kind of a big deal, right? If 1 and 3 are the same, especially since 3 is not a pillbox, so it would have to be either both Fs or both Ts, which is a very kind of influential, very limited kind of possibility. Or alternatively, this is also influential, that 2 and 4 would both end up being TAMs. You would be able to lock down 2 out of 5 positions right there. So now that you can kind of see this rule from this angle, this makes for potentially a great candidate for exhaustion, right? Either one of these things will have to happen, one or the other, and whichever way you go, it's going to be kind of significant. Anyways, before we do that though, let's kind of finish this off. The last rule, if 3 and 4 are both TAMs, then 1's going to have to be a pillbox. So I guess we can say that if 3 is a TAM and 4 is a TAM, then 1 is going to be a pillbox. And of course, that's kind of situational. That's if 3 and 4 are both TAMs, of course. So yeah, we can't really do too much with that up front. Let's go back to this. So we say we only have 2 major plays. Either 1 and 3 are going to be the same, Although even now we can kind of split into two possibilities. Either 1 and 3 are going to be F's, or they're going to be T's, because we know that they're definitely not going to be P's. Or alternatively, 2 and 4 will both be TAMs. Oh, and that's great, because if 2 and 4 are both TAMs, we also know that 5 is also going to have to be a TAM because it's the same as 2. So you know what? Let's exhaust based on that. We only have 3 plays here. 2 of them are if 1 and 3 are the same, so we could have either they're both F's or they're both T's, or alternatively, 2 and 4 are both TAMs, in which case we can lock 2 and 4 as T's. And we know that since 2 and 5 have to be the same, then we know that 5 would also be a T as well. Now, anything else we can do here? I suppose we know that the third position is never going to be a pillbox, but that's really only relevant in the third scenario. We can just leave a little reminder that this is not a P. Now this rule right here, if 3 and 4 are both TAMs, I suppose that could potentially apply. I mean, here that's out of the question because that's already F. But in these two scenarios, well, in the second scenario, that wouldn't be able to happen because if 3 and 4 are TAMs, then 1 is supposed to be a pillbox, but that's not going to work, which means in that scenario, 4 cannot really be a TAM. We can say that that wouldn't be able to happen. So that's pretty good. Now, in the bottom scenario, I guess you could still have 3 and 4 be a TAM, but then 1 would have to be a pillbox, which is arguably still okay. Actually, yeah, that would still be fine. Cool. Okay, I don't think we can do much more with this. So let's go into the questions. Question number 18, which of the following could be a complete setup 1 through 5? So for these questions, we always go by the original rules. First rule, max 2 pillboxes. Going through the answer choices, A looks okay, B has 3 of them, so that's not cool. C, D, and E are all good on that. Next, 3 is not a pillbox, and A is in violation of that, so we can get rid of that. Next, 2 is the same as 5, so C, they're the same, D, they're the same, E, they are different. We can get rid of E. Next, so if 1 is different from 3, so between C and D, well, in both cases, they're not different, so neither of those would apply. That would be fine. And lastly, if 3 and 4 are both TAMs, and that applies to answer choice D, then 1 is supposed to be a pillbox, and that violates it. So the best answer here then becomes answer choice C. Next, question number 19. If exactly 1 TAM is displayed, so if we have exactly 1 T on the board, well, right away, let me just label these, but right away that locks us into our first template here, right? Because in these two scenarios, we have way more than 1 TAM. So if there's only 1 TAM, we're going to be stuck in template A. But moreover, 2 and 5, they have to be the same. So TAM can't be in either 2 or 5 because we're only supposed to have one of them. So that means that the TAM would have to go into the 4th position. That's pretty good. And then from there, I guess everything else is kind of flexible. I guess you could have P's in 2 and 5 or even F's in 2 and 5. So you know what? Let's see if that's enough information. We can kind of try to keep this in your head that in this scenario, if there's exactly 1 TAM, it would have to go into this position in template A. The question asks what must be true. 3 is a TAM, that's wrong. Answer choice B, 4 is a TAM, that's true. We definitely know that 4 would end up being the TAM. Best answer for number 19 is B. Next, actually, you know what? We have a pretty good exhaustion. Let's go in order. Question number 20. Which of the following must be true? Answer choice A, no more than 1 pillbox is displayed. So does that have to be true that we have no more than 1? Could we have 2 pillboxes? And I mean, arguably, why not? I mean, in the top scenario, couldn't you have a P here and a P here? And then 4 could be the TAM that we had a moment ago? And yeah, that seems fine. It doesn't seem like it has to be true that there's no more than 1. Answer choice B, no more than 3 fedoras. Are we limited to only 3 fedoras? Could we have 4? And actually, in that same scenario, again, could we, if this was a TAM over here, or even a pillbox, couldn't we have had F in 2 and F in 5? I mean, that doesn't really, I mean, the last rule wouldn't apply and everything else seems to be easily in compliance, so that doesn't seem like it has to be true. In fact, couldn't we even have 5 fedoras as far as we're concerned? Actually, yeah, nothing says otherwise. There's no limitation on fedoras that we have, and the few rules that we have, this rule only tells you if 3 and 4 are TAMs, so that just wouldn't apply. So yeah, there's not any kind of limitation on fedoras, really. Anyway, answer choice C, no more than 4 TAMs are displayed. I guess the question becomes, could we have 5 TAMs? And maybe, template B or C, could we have had just TAMs across? Oh no, that would never work, because if 3 and 4 are TAMs, then 1 is supposed to be a pillbox. So there's no way to have 5 TAMs. So yeah, that would have to be true. There would be no more than 4 TAMs. Best answer to question number 20 is C. Next, number 21. Which of the following cannot be true? Answer choice A, 5 fedoras are displayed. Now, we did just kind of discuss that, and yeah, in the top template, nothing's really stopping you from having 5 fedoras. It wouldn't trigger any of the rules, and no other rules say that you have to have anything else, so that doesn't seem like it can't, there's no reason that that can't be true. Answer choice B, 4 fedoras and 1 pillbox. Now, in that same scenario, could we have had, as long as the pillbox is not in 2 or 5, so the pillbox could go into 4, and then 2 and 5 would be your fedoras. And that seems okay. Again, the only other kind of messy rule is this last one, but it only applies if you have 3 and 4 be TAMs, which that wouldn't be a problem. So that seems like it easily could happen. Answer choice C, could we have 3 fedoras and 2 pillboxes? And maybe in that top scenario, could we have 3 fedoras and 2 pillboxes? And maybe, because if 2 and 5 are pillboxes, then yeah, why couldn't you have a third fedora in number 4? That doesn't seem like it would break anything. Answer choice D, could you have 2 pillboxes and 3 TAMs? So I guess that would be in either one of these 2 templates. So 2 pillboxes, well, in the last template, that would never work, because 2 pillboxes would force you to have a pillbox in 3, which we can't. But what about template B? Could we have had 2 pillboxes and 3 TAMs? Well, hang on. If we have 2 pillboxes, they would have to go into 2 and 5, wouldn't they? Because then, those 2 are supposed to be the same. So you would have to have this be a pillbox and this be a pillbox, but then 3 TAMs means that you would have to have a TAM in 4, which we can't. We said it's impossible for us to have a TAM in 4 in that scenario, because if 3 and 4 were TAMs, then you would have had to have a pillbox in 1, which doesn't happen. So that cannot be true. There's no way to have 2 pillboxes and 3 TAMs. Best answer to question number 21 is D. Lastly, question number 22. If 4 is a pillbox, well, if we have a pillbox in the 4th position, I suppose that locks you into, I guess, one of these 2 templates, one way or the other. Would we be able to figure out anything else? And no, I'm not sure that we can. That feels like a bit of a dead end. So it's obviously not template C, but templates A and B are wide open. So okay, maybe that's enough information. If 4 is a pillbox, so just remember that this has to be a pillbox. Let's see what we can do based on that. What could be true? A, exactly 1 TAM is displayed. And no, because if you put in this template, if this is a pillbox, then either 2 and 5 are both TAMs or neither is. So we can't have just 1. And in this scenario, we have 2 TAMs already, so that wouldn't work. Answer choice B. Could we have exactly 2 pillboxes? And same kind of problem. If you put a pillbox into 4, then either 2 and 5 are both going to be pillboxes, which we can't actually do because we're maxed out at 2, or neither will be, but then you only have 1 pillbox, so that couldn't work. Answer choice C. Could you have exactly 3 fedoras? Well, if a pillbox is in 4, that would have to be in this top template. And could you have exactly 3? And no, because 2 and 5 are either both going to be fedoras, in which case we have 4 fedoras, or neither is going to be a fedora, in which case we only have 2. We wouldn't be able to do exactly 3. Next, can we have exactly 4 fedoras? And that lines up. If 4 is a pillbox, then yeah, you could have 2 and 5 both be fedoras. That actually looks pretty good. Just in case, answer choice E, exactly 5 fedoras. Well, no, if 4 is a pillbox, then obviously we can't have 5 fedoras. So once again, the best answer here is D.